The
All right,
project
good morning. Oh, what's up?
project of the week look okay, Brad? I tried to sew it together a little tighter in the email, so hopefully it follows well when we get to it.
Looks good to me.
Okay, sorry, Matt, go ahead.
All right, good morning. Welcome to another Friday
Tom.
morning safety meeting. Today is the 14th of August, so we're already almost halfway to September, which is pretty crazy. We are 8 days out of first aid injury. We do have a couple guys that been tweaking muscles and stuff here and there out there, so just be careful. Make sure we're stretching out good in the morning, even if we're not doing a formal stretching routine, that we're getting limbered up. We're 16 days out of recordable injury and 2 days out of vehicle incident. Today, we're going to talk about controlling potential energy, and specifically, we're going to talk about lockout, tagout procedures. So potential energy is, if you think about it, you raise up a pencil, and if the pencil's sitting on the ground directly, then it doesn't have potential energy. Once you raise it up, that energy that it possesses that it could fall with is what the potential energy is. So the little graphic here is a car sitting at the top of a hill. The definition of it is the energy possessed by a body by virtue of its position relative to others, stresses within itself, electric charge, and other factors. And we've talked about it a couple times in recent weeks, but when it comes to voltage and stuff like that, that's a difference of potential between two different sources. So the purpose of all this is it establishes requirements for the lockout tagout of energy isolating devices and types of hazards that we need to control our electricity, de-energizing machines or equipment, and all potential energy scenarios. So for electricity, the electricians are going to have more of a robust program than the 98% of us, and this is tailored to 98% of us. So in the past, we've had some incidents where people have gone to work on equipment, something's jammed up or something to that effect. Equipment's still running, somebody hits the wrong control, and it ends up injuring somebody. So it's really important that we actually lock out, so shut off, remove key, and mark that the equipment is out of service before we do anything, and that it's in a fully grounded situation. So our big one is these out of service tags. A few years ago, we handed them out to all the crews, but if you don't have one at this point, because there's a lot more crews out there, just let myself or Matt know, and we'll give you more flags. So if you have a piece of equipment that needs to be worked on, it's not safe to run, or you're going to be working on it, you want to take one of these, attach it to the door or to the controls, and prevent somebody from starting it. Especially difficult with lockout on equipment because all the equipment has the same keys, so you just need to be mindful of that. So we want to prepare for the shutdown of whatever equipment to notify all affected personnel, shut down the machines or equipment, and we want to disconnect it from its energy source. So if it's really a big deal, we want to disconnect the batteries. We want to disconnect the energy isolating devices and physically located and placed in the off position to disconnect from its energy source. We want to apply the lockout tagout device, which for some cases in specific situations would be the locks and keys, but for our everyday use is just the tags. And we really want to make sure that we're talking about this during our JHAs every morning. I think a lot of our stuff stems back to not really digging into the details of our JHAs. So we have this whole section on there. So I'll read through real quick. Do not place yourself under or between a load. That load above you has a lot of potential energy. You never want to suspend a load without a spotter. You want to lock out or restrain any equipment or loads without that may possess potential energy. You want to secure and inspect any high pressure hoses. Those can be very dangerous. We would never climb on or ride a suspended load because then you yourself have potential energy. We want to place or secure tools where they will not fall from above. Having your tow boards and stuff installed on any guardrails is really important. We want to lower aerial lifts and all-terrain forklifts when not in use. They will settle. And we want to stay clear of rotating drill string. So don't step over it. If you're going to be setting up on a drill job, you want to flag out around there. And the big thing is just use common sense. So if you need to do something special for the machine that you're using, just go ahead, do the extra steps. So that way nobody's getting hurt while they're working on something. In past years, we had a lot of instances with the spiking machines on the railroad because they'd always jam up constantly, and then people would go to you jam them and they get their fingers jammed up. So
Yeah, it's a big one. Potential energy. It's all around us, all over the time. It's really hazard recognition is key. So don't let your guard down out there on a day-to-day basis.
And when we want to lock out and tag out certain things, you guys still have, do we still have used those locks on certain things?
We do have locks if need be, especially on like a GC job with other multi-employers that has its
Yeah.
own additional locks that aren't our typical 383s.
Yep.
Yep.
We can get those from you guys. Thank you. All right, can you see the screen?
yes, sir.
Okay, thanks, Tom. Thanks, Matt. Okay, code item this week, don't overpromise or undeliver. So be honest and realistic and add some contingency and build in reserve for unknowns. I think that's always a good one. Don't overpromise, especially the project managers. Don't overpromise that the guys are going to get something done on Friday if it's not realistic. I used to love getting to a job and then they would say, Alan Pigeon said you would be done on Wednesday. I'd be like, we got 3 weeks of work here. How are we going to get done on Wednesday? Ownership topic of this week is just to help each other. And I had Sarah help me tweak this one a little bit. This is an important one. It's crucial for our success. When we help you can read this. I think it's helpful, but the essence of it is that when we help each other, we're also helping to get things done safely, more efficiently, and we're doing it right. The part that Sarah wanted me to add in here was the important emphasis on sharing your knowledge and empowering others. Give them the tools and the info and the support they need to be successful. Don't just watch other people fail because it's costing us all. So help each other. Equipment focus of the week this week by Chico. Chico, are you out there? Do you want to walk us through this one or you want me to?
I think you're better at it, Ben.
Well, I'll tell him the story. I asked Chico the other day if he had a focus of the week, and he said no. And then about 1 second later, he passionately dictated this to me. This one's called Stop and Think. So if something doesn't seem right when you're out there on the equipment or using our tools or doing anything operationally here at ECI or even in the office, if something doesn't seem right, stop and think about it. Just take a moment to reassess what's going on, listen to your gut. Something feels wrong, don't ignore it. That extra minute can help prevent accidents and injuries, and also it helps us from damaging equipment. And of course, it's going to help us avoid unnecessary costs. So we are reminded by Chico that we are an employee-owned company. He reminds us of that a lot, which is good. So protecting our equipment and each other, preventing unnecessary expenses helps protect all of us. So stop and think. Something doesn't seem right. It sucks to after something breaks or we do something wrong that cost us a bunch of money when we say, yep, I knew that was about to happen. So it's all about impulse control, right? Control your impulses, impulsive behaviors. So thank you, Chico, for that one. Anybody have anything to add to that one? Stop before you do, think before you do. It also works a lot in communication, and it's highly related to code item number 11, which is to strive for restraint, discretion, and integrity.
STAR protocol.
That's right.
Stop, think, act, review.
Yep. It works. It does work good for communication too. Wellness challenge. We've got these decals. They're 4 inches by 8 inches. I've got one here, if you can see it. They're on the desk next to the plotter. And like if the You can use them on your cooler if your logo gets messed up. Or you can use them for something else if you're in the challenge and you want to put it on. They're nice decals, high quality, probably the same material that we use on all our good decals. So they're right here. There's a stack of them in a plastic bag. Don't take them all, please, but come and grab a couple if you want. They're right there next to the plotter, next to Mark Pelquin's office. Okay. Project of the week this is, I believe, a joint effort from what Brad said. He's going to be going back and forth with Mr. McKinney. So I can drive this if you guys would like, or you can, whatever your choice.
I
Yeah,
can drive, Brad, unless you want to.
Sure.
You want me to stop sharing and you can put it up?
Yeah. How's that? Can you guys see that? Is that big enough?
Not bad. There you go. 130 usually works pretty good. There.
All right. So ECI was contracted with VTrans to replace a failing stone masonry pier under Bridge 132 on the GMRC in Cavendish. Bridge 132 is a skewed two-span through girder bridge, making the temporary and permanent work challenging. Our scope included permitting, establishing access to the river, constructing a temporary stone fill causeway, building a shoring system to support the bridge and trains during construction, constructing permanent cofferdams, driving piles, building concrete footings, piers, and a pier cap. That section or the elevation view there is kind of the most important drawing we had in the plan set, showing the existing pier and the new structure being built around it and kind of through the existing pier after we demolished it. ECI mobilized in late January 2026 to clear the permitted access, establish an access road through the wetlands, and construct a temporary causeway in the Black River. No practical access existed to the upstream side of the bridge, meaning that all earth-moving equipment used on that side of the project needed to be small enough to fit under it or had to be flown over. And there was about 7 feet of clearance between the causeway and the bottom of that girder. So it was very tight. And yeah, using the new Tadano crane to lift a 70 or yeah, I think that
80.
was the 80 over the bridge to continue placing stone fill there.
We had some pretty heavy stuff to do on that side of the bridge. So ultimately we ended up flying a 130 over and back many, many times throughout the project.
Nice photo.
After establishing access, building that road through the wetlands and filling in half the river, crews installed a temporary pile supported shoring system to support the bridge for the duration of the project and maintain train traffic. So the original VTrans did some permitting on the job. They had permitted to fill in the other side of the river, which didn't work well. It was disconnected from the available staging. It was right off the edge of the highway. I think it's 103 right there. So we re-permitted the project to flip the causeway over to the shallow side and the side with access, which made a lot more sense for us. So, obviously in replacing this pier, this masonry pier, long process, and it needed to not be there. And, often when we do bridge seats, we'll jack up the dead load of the bridge and really quickly demo it out, or potentially short off a floor beam for live load. In this case, that wasn't possible. So we had to go from the ground up to support the bridge during construction. And so we did a contractor designed shoring system using piles, and you can see it here. Each shoring tower consisted of 8 H piles. So you got 1 tower here, 1 tower here. So 4 piles on each side, driven to refusal, heavy piles, HP 14 by 117s. And then 2 cat beams on either side, heavy wide flanges, W18 by 119s, and a distribution beam. So you see the cap, you see the big beams that span all the way under the bridge. And then these distribution beams are meant to avoid concentrating the load on the relatively slender web section of the through girder. Total design load for each tower was almost 700,000 pounds, with a total supported load of well over 1 million pounds. We engaged Tech Associates out of South Portland, Maine to design the shoring system. We did perform the geotechnical and pile design in-house. Tech is a great engineering firm that specializes in railroad bridges, and they're really a contractor's engineer. I mean, they do a lot of work for railroads, but they're also very pragmatic and practical. So we've used them. We do most of our shoring designs in-house, but when we get to really heavy, complicated, high loads that have to take into account, the existing integrity of the bridge, sometimes we'll engage those guys. They did a great job. This is a little bit unique because it's a 2-span bridge, simple spans landing on this pier. So supporting the bridge for many, many months, here and here, created these 2 short cantilevers. This isn't a continuous connection here at the pier. There's no continuity with the cover plates, and there's just a few rivets inside that really aren't doing anything. So this bridge is really, a continuous span with a cantilever and then another cantilever over. So we were a little nervous to see how it worked, but it worked quite well. To jack it, to actually get the load up off the pier, we put some heavy tubing on the bottom flange of these heavy beams. Got a little daylight, demoed it out, and then let it sit back down, using some hemlock plank to let the rivets crush into it and support it evenly.
After using the temporary jacking beams to get the load into the new shoring system, ECI removed the chains and binders that had been holding the masonry pier together and quickly demolished the pier below the channel elevation. And demolishing it below that elevation was critical for the new pier because there was about 2 foot of room between the bottom of the pier cap and river bottom per the design. And here Nick is pulling out those masonry blocks. They were all just dry laid and kind of infilled with small cobble and cuttings from the granite chipping and shaping process.
Yeah, there wasn't much holding that thing together besides the binder, so it came out pretty quick. You can see we took the ROPS off that machine. Just there's no other way to get it under, and we had a bunch of work to do under the bridge too. So the next step was to build permanent sheet pile cofferdams. Even though that was permanent work, it was still contractor designed. So we designed those in-house. So the cofferdams was a closed cell, 3-pair by 2-pair down. But it was kind of funny because it's contractor designed, but it's permanent. They were relying on those sheet piles for the scour protection of the new footings for the piers. Getting those sheets in was a real challenge due to ground conditions and the close proximity to the bridge and the pre-existing portion of the masonry pier below that remained. We knew we'd have hard driving. The boring showed some really dense soils, but we also thought that they put it really close to the existing work, and we were worried about hitting the pier, and we did hit the pier along with a bunch of cobbles and obstructions that weren't shown in the borings. Ultimately, we were able to recover a lot of that effort through the change process.
Yeah, that photo is showing we pre-dug the entire cofferdam perimeter and interior, and we're just test driving some sheets to see if we reached everything. Of course, the biggest machine we could get over there was a 130 with about 14 foot of digging depth. So we had to go deeper than 14 feet, but after 14 feet, we felt confident that we removed all the obstructions and then backfilled and installed the permanent sheet pile. Due to how close the sheet piling was to the bridge, we had to do some creative pile driving. We ended up welding an interlock about 6 feet on either side and grabbed onto a single pair to drive that corner because it was within a foot of the bridge where the hammer wouldn't fit on it.
You can see a brace section in here. This was ultimately a braced excavation, so we used basically a moment frame, no tiebacks, but just a a steel frame, but it also worked nice as the pilot jig. This had to close. You're in a river, so we had to close it up for water purposes. So that jig ultimately braced those sheets from coming in once we dug it out, but then they also served as a template for driving. After the cofferdams were excavated and braced, we dewatered. Even though we closed the sheets, you're still in a river, and the river elevation fluctuated a lot. It's pretty clean gravels up top, so you have a lot of interlocks weeping and groundwater coming up through. So ultimately, it took several 5 horsepower 3-phase pumps, both 3-inch and 4-inch, to get things under control. Eventually, those interlocks silted in, and we got ahead of it. So once the cofferdams were excavated, we had 9 permanent H-piles that would support the new footings in each one that were driven down inside the cofferdam. There's a little bit of phasing there because the hammer wouldn't fit on them because they're so close to the brace on one side. So we drove 3 up top, dug around them, got to the bottom, dewatered, and drove the last 6 on each side. Those were also those heavy HP 14x117s. You can see here a bird's eye view from a man lift, rental diesel hammer. Needed to get something a little bigger to develop the energy required than the one we own. You can see one cofferdam there.
Yeah, after we fully excavated, we prepped the subgrade. You can see all the piles were cut off to grade down there. And we formed and tied the rebar. It was a 4-foot footing on each side. And as soon as we were down to subgrade elevation, we were diligent to get above ground again. So we quickly formed that. And then we used 7-foot diameter gang forms to form the piers after the footings were cured, with a very heavy anchor bolt system to connect the pier to the pier cap. We elected to use a 2-piece anchor rod so we could remove that and fly the rebar cage in later.
You can see the
After-
couplers. Sorry, Brad. You can see the couplers sticking out of the pore there. So yeah, like Brad said, we needed the extension of them to get the templating correct. Here's a jig that the guys made. So to get them just right and support them from above, because you can't support them from below. But then I took out these stub pieces so we could do the work above them and ultimately threaded them back in. So some pretty tight layout there by the survey team and our guys.
Yeah. So after we backfilled those cofferdams, we cut the sheet piles off in the wet. And Hydro Pros out of Danville, Vermont came and they used carbon arcing to cut the sheets off under. It wasn't actually underwater in all conditions. It was so murky they had very low visibility, but they were still in the wet. Their bodies were, and at some points they were torching or cutting in the wet underwater, and cut all the sheets off and then continued with the rock fill.
You had so much water pouring in from the outside through the interlocks that even if we wanted to go and, work up to our chest in the water, oxyacetylene wouldn't do it. Just put your torch out. So we backfilled the entire area once we had the piers in. So you get your piles, you get your footings, you get your 7-foot diameter piers. Now it's time to build the cap, just a big concrete beam clear across them that's going to support the new bridge. And that cap elevation, the bottom of it is just about channel elevation. There's not much air underneath it. So we backfilled the area, cut the sheets off, backfilled that whole area, just 6 inches shy of that new cap, and poured a temporary mud mat. The 63,000-pound pure cap rebar cage was pre-tied. We brought in a sub for that, SRC Placers out of Mansfield, Ohio. We used them for the Richmond pier and deck as well. So kind of a consistent theme here, using subs and sub-consultants that we've used and trusted from previous jobs. We had them tied in the staging area, just a lot faster with access rather than do it in the river where we'd get flooded out and have to hump everything down with arms and legs. So we got that tied up top and then transport it down over the rail and then flew it into place using a creative system of channel rails and Hillman rollers to slide it in from the outside. The vertical clearance was just a few inches below the fixed bearings, which remained as part of the work. The cage was super flexible. It was like a big slinky, especially once you hooked off from one end and had it supported on the rollers and and we're nudging it in. So we used the 35 to nudge it along, and took a long time, a lot of little adjustments, but we got it. You can see it in the backside sitting on some blocking for the backspan. You can just see how much it's sagging as you're moving it in. So there's a lot of clearance and rubbing and stuff that we had to mitigate, but we got it.
With the rebar cage in place, crews began forming the pier cap. We used a combination of 9-foot diameter gang forms and Simon's forms, and got the 100 cubic yards SCC, self-consolidating concrete, pour done just before the 4th of July holiday. It was a very hot week, and the high temperatures on the Thursday the 2nd were forecast to be well into the 90s. We had the concrete on site at 5 a.m. and completed the pour within temperature spec for VTrans. This was a huge milestone since the project was flood safe and wouldn't be set back by any weather. You can see Carrera's boom pump in the background, along with a rental 228 flying the American flag for the holiday. And everything was formed up right here. This was mid-pour, I want to say. Guys were working underneath the bridge. We kind of filled it from 3 or 4 different locations, so that SCC was spread and what wasn't segregating but was placed properly. Already on the hose, and we went an extra step in consolidating around the forms. There was a really tight rebar right at the radiuses there in the transitions. We wanted a good product on the surface, so we went and vibrated around it as we were pouring.
Normally you don't vibrate SCC, but we told the inspectors it was really important to us because we could see where it wasn't consolidating just quite enough, especially around the bundled bar. You got bundled 11 bar in the bottoms, just I don't know how many bundles of 11 bar, but you got bundles triple 11 bar in the bottom, just boom, 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 boom. So we basically told them, like, look, if we get a bunch of rat's nests and honeycombing and voids, it's not on us, but we'd like you to let us vibrate it. And they agreed. And I'm glad we did.
Yeah.
Very lightly, just a little bit.
Yeah. With the bridge bearing on the new pier cap, the temporary shoring towers and causeway removal work began. The river channel, river bank, and access road were restored to existing conditions. And kind of the way this shoring tower was designed there, and the way we poured the pedestals, the masonry plates were bent up and not in good condition, so you couldn't just set it down flat on the pedestals. So we cast the bridge in its proper elevation, and then we torched out the support beams, the distribution beams on this, to relieve the shoring towers and the bridge and actually transfer the weight to the pier cap. So Isaac is there torching apart that beam, the photo.
Wow.
Here we are restoring the river, removing our causeway. Again, the water came up as we were doing this. This was like flood-ish number 6 for us, I think. So we kind of had all the equipment working, cleaning out the stone that we supported the mud mat with underneath that pier was a challenge. So Steve Bruce actually grabbed onto a cutoff pile and was using it as a grade beam to scrape the material and drag material out from under the pier there, which was pretty creative. I hadn't figured out how to do it yet, but he had a plan.
We did cast some chains into that mud mat. That was Dale's idea, to yank that out, and we used some Teflon or ultra high molecular weight sheeting to prevent the bond from forming there when we poured the cap on top of the mud mat.
And that's the final product right there. When we arrived, the inside of the curve of the river was significantly higher. It was a big gravel bar. So that's what we restored it to. And we re-armored the bank and put our straw matting down. And hopefully soon we get some rain and it grasses up for us for final inspection.
Nice.
And that's why we flipped the causeway. You know, they wanted us to do it on the deep side of the river that's like 8 feet deep. And, you know, when we were looking at this job last summer, it looked just like this. One side of the river's dry until it rains a lot. So this is obviously the side we wanted to fill in. And I'm glad we did.
Nice. Awesome job. Very technical, complex project done and executed in a really, really nice, organized way. It looks very organized when you show it to us guys, but I'm sure you had your days. So here's the Tilly Drive project from 2010. I think that was is that the first job that Matt Warzalak that you were brought to by Stu King?
Yes, it was. Brian Labonte, Rob Smith. doing
Yeah.
that one.
I found a few pictures. I took that one when I was flying over it, but that bridge is still looks pretty good. That was all helicals. I don't know who else is here that worked on that project. Larry Sullivan, I think, was the super on that project, but it still exists. I walked over it the other day. Pretty cool.
Yep.
Yep. Nice. All right, guys. Well, thanks for an awesome project of the week, Brad. It was well done, and Ben, thank you.
Thank you.
And back over to Matt.
Yeah, if you're watching a group setting, please send that over so you can capture attendance. But most importantly, let's have a safe day out there. Let's drive safe, work safe. Let's work together, team. Let's solve some problems. Let's have some fun
And help each other.
and help each other. Yes.
Okay. Thanks, guys.